Hello everyone. Today we are covering a topic called histogram. This is one of the most important topic we have in statistics, and this is the most used chart while doing the analysis and mostly on quantitative variables. For the categorical variables we have different charts, but for the quantitative variables histogram is one of the used chart we have to do the analysis on quantitative variables. So let's deep dive and understand all the concept of histogram. Here, this chart is representing standard normal distribution, and this chart we call as a histogram. This histogram you have seen on lots of the courses, on lots of the YouTube videos, on lots of the articles. Because most of the time while giving the example of histogram, we present or we represent standard normal distribution. But in lots of the example, or we can say in real life, every distribution not have a standard normal distribution. It's in a different form as well. So here and today here we will today we will try to learn a different kind of distribution, not a standard normal distribution, and by referring that example we will try to understand histogram in depth. So let's create a sample data set. Now here we are creating a sample data set of 700 students, and these 700 students have given a test, and that test have a range of 0 to 200 marks. So here after running this code we are getting this data frame, and this data frame has a 700 records, so 700 observation, and this is the just dummy data we have created just for plotting the histogram or for doing the analysis. So this column students represent student 1, student 2, and this second column marks represent the marks scored by these students. So here student 1 scored 132 marks, student 2 scored 48 marks. So today we are interested into the second column, and what kind of analysis we can do on this second column, and while doing the analysis which chart we can rely on, and the chart on which we can rely on while doing the analysis on quantitative column like this marks, and the chart is histogram. So let's plot the histogram. So first we will plot the histogram, and then after plotting that we will understand the histogram. So let's plot the histogram with a bin of 4. Now I'm plotting this histogram, and here in this code this line is the important line here, and other another lines are just for the enhancing that histogram below created. So I'm running this, and here this histogram is plotted, and here you can see it's giving a 4 bins to us now, and here one bin having a range of 50, 0 to 50, 50 to 100, 100 to 150, and 150 to 200. So this is the histogram looks like of 4 bins. Now we will try to understand all the components involved while creating the histogram. So let's understand the definition of histogram. So here the definition says a histogram is a foundational way to visualize numerical data by grouping values into intervals and showcasing the frequency of occurrence. So now here we have grouped data into 4 bins, that is into 4 intervals like 0 to 50, 50 to 100, 100 to 150, and 150 to 200. So here we can getting the sense how many students are present in this each buckets, like bucket 1 0 to 50, bucket 4 is 150 to 200. So here you can see 174 students are present in bucket 1, that is 0 to 50. Now let's understand the other elements in this histogram. So here x-axis represent the bins. This represent the bins, and these bins are created on top of these ranges 0, 25, 50 to 200. And then this y-axis represent the frequencies, like how many students are falling within each bin. So here in this first bin 174 students are present within the first bin, and in the last bin, that bin ranges from 150 to 200, 176 students are present. And this bins looks like a bar, and we can consider this as a bar. Then these charts is equivalent to a bar chart, but this is not completely directly likely to bar chart, because all the bar are connected to each other, and bar chart is used to plot the categorical variables, like to do the analysis on categorical variables. But in histogram we are doing the analysis on quantitative data like marks. So now we will check how these bin are formed. So here, and what is the bin? A bin is a range of values used to group data into histogram. And how bins are formed? The total range of data is divided into equal intervals. So now just consider, now we have to plot this histogram by using 4 bins. Then the range we have is, we know the marks present in our test is from 0 to 200. So the range is maximum marks minus by the minimum. So 200 minus 0, and now we are representing the histogram by using 4 bins. So divided by 4. So now 50. So each bin have a width of 50. So now this complete data is divided into 4 parts basis on the marks, and these 4 parts have a width of 50. So part 1 having width 0 to 50, part 2 have 50 to 100, part 3 have 100 to 150, and part 4 have 150 to 200, as we have divided this data into 4 parts. Now let's say, instead of dividing this 4 into 4, let's divide this data into 10 parts for the getting the deeper understanding of the data. So after dividing this into 10 parts, we are getting 10 bins. Like exactly, if you are dividing this data into 10 parts, that is means we are creating 10 bins, and the width of each bin is 20. So width of each bin is 20 marks. So when we are dividing data into 10 parts, then what one part is representing 20 marks. So let's change this our histogram code, and instead of 4, let's type this here. We want 20 bins. Oh, sorry, not 20 bins, we want 10 bins here. Yeah, so here we can see we are getting 10 bins, and each bin has a width of 20. Here 0 to 20, 20 to 40, 40 to 60, and this middle part of 50. So here this is 40, and there is 60, and this middle is 50 we have. So like this we have created this 10 bins. So we have divided this data into 10 parts, and each bin has a range of 20. So this is the interval we have from 0 to 20. So each interval has a width of 20. So within this first interval 0 to 20, there are 68 students who has score marks within this range from 0 to 20, and there are 72 students who have scored marks from 20 to 40, and there are 77 students who has scored marks from 180 to 200. So like this we have created this 10 bins, and now let's create 20 bins now. So here if you plot 20 bins, here this looks like this. So here if you make this a 20 bins, then one bin represent the interval of 10 marks. So here it is 0 to 10 marks, 10 to 20, and 20 to 30, and this middle represent 25, like this. So like this bins are formed. So it is depend upon us how many parts, in how many parts we want to divide our data, and after dividing that data into these parts, then we will get the width of each part. And here this is the formula that we are using for calculating the bandwidth, that is max value minus minimum value and number of bins. Here the max value we have 200 marks, minimum value is 0 marks, and the number of bins we want, that is. So each data points is assigned to one of these bins. So every data points, so every student definitely has score marks within these bins only, that we know, and this student definitely fall within one bin. Each student will fall. Then the height of each bar represent how many values fall within that bin. So here how many values means how many students are present within this bin. So here first bin representing 0 to 10 marks. So there are 34 students. So this height represents the 34. Here on y-axis you can see here the 34, just below this 35, and there are 34 students who have scored marks within 0 to 10 marks, and this been representing that count to us. Yeah, now here the thing is, if we have marks from 0 to 200 and use 5 bins, the bins might be bin 1 0 to 50, bin 2 40 to 80, bin 3 80 to 120, bin 4 120 to 160, bin 5 is 160 to 100. So yes, we have divided this complete data into four within 5 parts. So after dividing this data into 5 parts, that we represent, we know that after dividing this into 5 parts, we will get this data each bin represent 40 marks. So these are the bin 1, bin 2, bin 5. So here we will again change and we will give bin 5. Then here we can see 5 bins are created and each bin representing the width of 40 marks. And now the inside is, the more bins you use, the more details the histogram become. So here only the 5 bins we have. So here we are not getting the enough clarity that we have created only the 5 groups. But here instead of creating that, if you created a 26 bins or 26 groups, here we will get the detailed understanding of this data. Like within this bin, how many counts are falling, how many students are falling. So here we are getting a deeper understanding of the data. So now let's move towards the next concept. What happens at the bin edges? Yeah, this is the interesting topic we have. Let's say we are dividing this histogram into 2 parts only. So we have to create only 2 groups. So let's create 2 groups. So here 2 groups is, one group representing 0 to 100 interval and another representing 100 to 200 interval. So what is happening to students, those who have scored 100 marks, in which bin they are coming? Are they counted into the bin 1, those students who have scored 100 marks in bin 1, or they counted into bin 2? So yeah, let's understand these things, what is happening at these edges of this bin, in which bin these respective values are counted. So let's going down. Here we can see default rule, the left edge of the bin is included but the right edge is excluded. Yep, so here the left edge of the bin is included but the right is excluded. So here 0 to 100, so left edge is 0 and right edge is 100. So here those students who have scored marks 0 are included in this bin, and all the students like 25, 50, 74 are included. But the right edge is 100 for the bin 1. So this is excluded. So those students who have scored marks 100 are not included into the bin 1. They are included into bin 2. So now let's plot 4 bins. No, let's plot 5 bins. Here we have taken the example of 5 bins. So let's plot the data again into 5 bins. Yep, now we have 5 bins here and each representing the 40 width. So the bin 1 is representing 0 to 40. So in the bin 1, 0 marks are considered, but the right edge is 40. So this 40 is not considered into the bin 1. So 0 is included but 40 is excluded. And this 40 is considered into the second bin. So the range of second bin is 40 to 80 marks. So here 40 is included into the second bin, but 80 is on the right edge. So 80 is not included into the second bin. Like this, 80 is included into the third bin, but 120 is not included. And in the fourth bin, 120 is included, but 160 is not included. And in the last bin, the fifth bin, 160 is included. And here is a twist we have in the last bin. both the edges are included into the last bin. So this 160, the left edge is also included into the last bin, and the right edge, that is 200, that is also included into the last bin. So apart from all the bins, here in every bins the right edge is not included, but in the last bin right edge is included because there is no another bin. So definitely, like, we have to include that edge, include that value that within that bin. So here this 200 is part of this bin, the last bin. Yeah, so with this we have covered some basic topics of our histogram, and there are lots of the different topics and lots of the concept we have in the histogram, and then we have to compare the histogram with the bar chart, how these two are different and all those things, and that thing we will cover into our next video. Yeah, thank you, bye bye, see you in our next video.